Okay, good afternoon, everybody. This is kind of an interesting title for a presentation. It was given to me, so I struggled with trying to figure out what water and nitrogen implications are, what that means, and what Dan wanted. And I think I got it figured out. What I'm going to try to do in this presentation is I will talk a little bit about management, because you have to learn something. The rest I'm going to try and tell a story. I'm going to take you very, very high on a statewide level of what we think we know is going on with the data that we have about water and nitrogen recycling and forage production, corn and sorghum production, back down to the field level, so you know how these resources are being managed, and then talk at the end about where the regulatory agency and where dairy producer sponsored research is leading some of the recommendations for nitrogen management in these forage systems. All right, hold on. Just to give you a quick heads up, I'll talk about corn and sorghum, just some basic production stats. I'm going to contextualize them where they belong, with the animals and with the milk. I'll talk about nitrogen and water use by corn and sorghum forages, and I'm really going to be sharing some work that's been done before me by Bob Hutmacher, Jeff Dahlberg, and then Till Engerman with Ludorf and Scalmanini Consulting Engineers, who's the technical researcher for the Central Valley Dairy Representative Monitoring Program. That'll come back up, so you remember that. Also talk about nitrogen and water availability in California for forage production, and I'm going to rub my crystal ball and tell you what the future landscape probably looks like. All right. Corn and sorghum in California are important for dairy. This comes from our 2017 stats, the most reliable updated stats that we have on production. Our corn acres in 2017 for silage, 345,000 acres, which is down about 15% from our average of about 410,000 acres in California of silage production. All in all, that amounted to about 9 million tons of silage corn in California in 2017. Sorghum, we don't have great numbers. We have to pull it together from County Ag Commissioner pesticide use reports, but the indications we have are that over the last 5 to 10 years we have a fluctuation of about 60 to 90,000 acres of sorghum, and it tracks pretty well with water availability, surface delivery. The yields range in our survey of some growers out there when they're harvesting. Yields range from about 8 to 25 tons per acre. A lot of that has to do with cultivar, but I think even more has to do with water management. Dairy animals, 1.7 million cows. It's been pretty stable for quite a while. It's not really going down. And their replacements, which don't get talked about a lot. It's almost a one-for-one. That includes the milk-fed calves, the larger calves, heifers, everything up to the calved and milking cows. They're distributed on about 1,300 dairies in the state. Our 10-year average of milk production in California amounts to about 40 billion pounds per year. It's a $6.5 to $7 billion a year industry. Almonds might have caught up with us in that value. So we talk about low-value crops, corn and sorghum and wheat and alfalfa usually get lumped into that category, but just remember they wouldn't be here if it weren't for that $7 billion commodity of milk. These numbers are important. I'm not saying them to impress you, but they're important because I'm going to use these in some calculations as we go forward so that I can help show you how we come up with our nitrogen balances in manure excretion in California and where it's going. I'm going to take it down to the ground a little bit. Western Fertilizer Handbook gives a possibly high estimate on nitrogen, pounds of nitrogen removal per ton of corn harvested, about 8.5 pounds. More common and more conservative estimate is about 7.5 pounds. Has a lot to do with crop fertility. Sorghum, I'm going to use the number of 10.5 pounds of nitrogen removed per ton of forage. It comes from some unpublished data. We're pulling it from forage that's grown on dairies fertilized with manure. But I want you to be aware that Daniel Geisler, our nutrient management specialist, has put together an excellent report on the removal of nitrogen in harvested plant parts that covers about 90 to 95% of all of the irrigated acreage in California. He came up with a little bit lower number. We think that the bias in that number might be that the data came from variety trials, cultivars that are not necessarily all typical to dairy forage production and are not being fertilized with nitrogen at the rate that it's being fertilized on dairies. So we think a more typical commercial representation is this 10 to 10.5 pounds. That's what I'll use in my calculations later. What about water? Cool. This is some data that was put together by, I believe, Larry Schwankel. Differences in planting date and daily crop evapotranspiration for corn. In general, solid long season crop of silage corn in California will evapotranspire about 25 inches of water. About sorghum. This slide comes from Jeff Dahlberg, showing on the left axis the tons of crop that you get per inch of water. So here I'm in the green box, I'm comparing typical silage corn, which gets you about 1 ton of crop per 1 inch of evapotranspired water, versus some more typical cultivar types for forage production on California dairies, like a non-BMR or a forage sorghum BMR, that gets you about 2 or 1 3/4 ton of forage per 1 inch of evapotranspired water. What does that mean when we actually start irrigating and fertilizing these crops? This data comes from a study that Jeff Dahlberg, Bob Hutmacher, and I have been working on over a couple of years. This is just one snippet of that study. Here we're comparing yields between a long season forage corn on your left and mid to long season brown midrib dual purpose corn, sorghum on your right. Now the left cluster on each of these charts is what we're calling a deficit irrigation, about 50% of the water that a long season full yielding crop of silage corn would require, so about 12-13 inches of water. The second cluster is that 75% of irrigation applied, and the third cluster on the right is what we would consider full season evapotranspiration applied to that crop. And the colored bars, the amber or orange is our zero nitrogen or no supplemental nitrogen added in season. These plots were fertilized with some, I believe, monoammonium phosphate or 1152O to correct some phosphorus, but otherwise no nitrogen in the in season. The green is what we're calling optimal nitrogen application for forage sorghum, so about 100 to 120 pounds of nitrogen per acre applied, and that blue bar is optimal for forage corn, so about 250 pounds of nitrogen per acre applied. These were fertigated through and irrigated on buried drip, mostly to help with the distribution uniformity. What do we see? Well, when you don't irrigate corn, you don't get anything. It doesn't matter how much nitrogen you put on it. So Jeff might have something to say later about water use efficiency of corn. But with sorghum, at about 50% of the water that you would apply to corn, you do see a little bit, about a 4-ton increase with just a modest amount of nitrogen applied to that crop. As you move toward the right, though, with the corn, you continue to see a yield response with additional water and additional nitrogen. That's not surprising. This is not the first corn nitrogen and water study. With the sorghum, however, you do see a sort of saturation or leveling off of that response. There is a maximum amount of water, a maximum amount of nitrogen that crop will respond to, and you see that leveling off there. Now, what about on a statewide level, water and nitrogen? Thomas Harder presented this graph 4 years ago at the Western Alfalfa Symposium as we were trying to figure out what the Sustainable Groundwater Management Act meant. This graph shows in that red line a cumulative decline of groundwater storage over 90 years up until 2010 in the groundwater basins of California to amount to a cumulative 130 million acre feet of cumulative overdraft of our groundwater basins. So what? Well, the law has defined boundaries of groundwater basins in the San Joaquin Valley as being critically overdrafted. In legalese, critically overdrafted is when continued practices of water management would probably result in significant adverse overdraft-related environmental, social, or economic impacts, or you can just say that means no business as usual, not allowed. Why is that important for the southern San Joaquin Valley? Here's just a precipitation chart produced by the California Data Exchange Center that tracks precipitation, snowpack, reservoir levels in California. That 28 inches of precipitation in our watershed, in the mountains, is not enough to sustain the irrigation required by all of the crops in the southern San Joaquin Valley, and that average has a range of about 45 inches of water, so our normal is all over the board. What about nitrogen and also phosphorus and potassium for fun that's excreted in manure? Now, this information is derived from our CDFA, California Department of Food and Ag production statistics, and the American Society of Ag and Biological Engineers estimations of nutrients excreted in dairy animal manure. That's how we came up with these numbers. I didn't make these up. In 2017, we estimated 170,000 tons of nitrogen excreted in manure from the dairy animals, including their replacements, 27,000 and 64,000 tons of phosphorus and potassium respectively. Those are elements that get recycled in the crops, recycled in the soil, placed in storage, used in bedding, exported off of the farm. So it's not all eco-disaster. I will explain this pie chart and how I got to it. So take that 170,000 tons of nitrogen excreted per year, use the estimated credit of 30% of that being volatilized in handling of the manure from the point that it's excreted to the point that it goes into a storage facility like scraped stockpile or a lagoon. You end up with 51,000 tons left. That leaves us with 120,000 tons of nitrogen remaining to be managed. Using the Western Fertilizer Handbook and the data that we have from nitrogen accumulated in plant parts for corn and sorghum, that means 36,000 tons harvested in corn each year, 6,200 tons of nitrogen harvested in sorghum. That leaves us with 76,400 tons of nitrogen left to be utilized elsewhere. Now, we double crop in California with our forage systems, but your small grains, which are, if we assume they're grown on the same acreage as our summer forages, at maximum would utilize about only 2/3 of that nitrogen in the harvested plant parts. There's a lot of nitrogen out there to be utilized. problem is that in a study of the annual summary reports to the Water Board and what we know is being produced and what we believe we know is being excreted in nutrients, Christine Miller, Trish Price, and Deanne Meyer found going through that data that out of the nitrogen that we estimate is excreted, there's a whole heck of a lot of it that's not being accounted for in the reports. After you discount the volatile losses, you discount what's been exported off of the farm, and you discount what's been applied to the cropland, there's still a bunch of nitrogen we haven't accounted for in that system. Where did it go? The paper goes into that and gives a lot of hypotheses that I won't get into, but it's very interesting. Then when you get to the field and you just look at that applied fraction, which is that graphic on your right, you estimate how much might be lost to groundwater, how much would go to volatile losses in the air, either as ammonia or denitrified in the soil, and then what comes off in the harvested crops. For some reason, what's being reported coming off in harvested crops tends to amount to more than what's actually been applied. And it's not a single year look. It's over multiple years. There are consistently reports of more nitrogen coming off the field than is going on year after year. This is a problem that we have to deal with in terms of how this information is reported and how to get accurate information about how nitrogen is cycled on a statewide level. This isn't pointing a finger at anybody doing anything malicious, but it's an imperfect system that we have not quite figured out how to use yet. How to move forward? Well, the Central Valley Dairy Representative Monitoring Program, I told you that would come back, is a quasi-regulatory and producer-sponsored group that has undertaken the largest in all human history groundwater quality trend monitoring study. So hundreds and hundreds of groundwater monitoring wells on representative dairies throughout the state of California, monitored for about 10 years to look at groundwater quality trends. Special studies on leaching from corrals, leaching under lagoons, and nitrogen recycling on cropland, and that data we're still analyzing. Oh, great. All right. I'm going to go through every one of these. So their recommendations in their summary representative monitoring report to the Water Board, I'm not being facetious. It really is an interesting report. If you have been tracking what's going on with nitrogen regulations on dairies in California, this report is essentially a 180 from what the industry's position has been in acknowledgement of responsibility moving forward with managing nitrogen that comes from manure and is recycled on dairies and exported off of dairies. It's a very, very interesting report. In that report, they recommend to the Water Board that we focus on a whole farm nitrogen balance. They want to identify where that unaccounted for nitrogen is and figure out if it can be agronomically applied or whether or not it needs to be exported. They want to improve industry nitrogen use efficiency. Their stated probable change is that they want to increase the precision of nitrogen application regarding crop demand. That's job security to me. Anybody can figure out how to adequately spoon feed a crop with nitrogen from manure. I have a job for you. Increase manure nitrogen exports. The CVDRMP came up with a very similar figure to what the UC Davis researchers figured out. A lot of nitrogen being unaccounted for in those reports. At the end of the day, even what is accounted for, it becomes very apparent that it cannot all be utilized on dairy forage crops under current management practices. A lot will have to be exported if production continues as normal. They want to make better technical recommendations, improving the monitoring, reporting, and nitrogen management practices on dairies associated with cropland. That stuff is likely going to be folded into a brand new Dairy General Order, and part of what the CVDRMP wants to do is now act like a third-party coalition, much like in the Irrigated Lands Regulatory Program, and they would initiate and track the education of growers on improving those practices and documenting the impacts of the practices, much like the third-party coalitions do for other irrigated agriculture. And that's it. That's what they're recommending. Takeaway, dairy is what's driving corn and sorghum production in California. Water for forage production is predicted to be limited. I should have corrected that. Water for crop production in California is expected to be limited. Manure nutrients are already being excreted in excess of what can be agronomically applied. That's because we don't have the technology to convert these manures into products that are have enough value to be exported and utilized on other crops. There's not a commercial infrastructure yet for utilizing these manures on other crops that's sufficient to export this manure. That numerator has to come down somehow on the dairies. Either they stop excreting as much or that manure goes somewhere else. Now the regulatory agencies and producers, by way of this CVDRMP, Summary Representative Monitoring Report that came out in April of this year, are insinuating or implying, there you go Dan, that more innovations and restrictions on manure nutrient applications are likely to be required. And I hope I teed this up for Steve Kafka, my colleague, to come follow up and maybe tell us what we ought to be doing other than growing corn and sorghum. Thank you.